Hello, good evening students. In previous class we have learned output equation and selection of specific magnetic loading and selection of specific electric loading and calculation of C naught. So in this class we have to solve some problems. So problem number 1, determine the approximate diameter and main length of stator core, number of stator slots, number of stator conductors for a 11 kilowatt 3 phase 4 pole 1425 rpm delta connected induction motor. B average 0.45 Webers per meter square, AC 23,000 ampere conductors per meter, full load efficiency 0.85, power factor 0.88, assume L by tau equal to 1. Stator employs double layer winding. So this is given problem. One problem may have 10 marks. It may consist maximum 10 to 12 marks. So what is very easiest way? In last class I pointed out, you have to remember C naught equal to value, then Q equal to value, then synchronous speed. Before going to that, you write down in symbolic manner all given data. You write down L1 kilowatt, delta connected, B average, AC, 1425 rpm, efficiency, power factor, all given details you write down one side. After that you start with initial thing. So kVA input Q equal to output divided by efficiency into power factor. Output should be in kilowatt. Then given machine has in kilowatt. So you substitute all the values, we are going to get as 14.7 kVA. Next, number 2, synchronous speed ns equal to 2f by p. So you substitute, we are going to get 25 rps. Stator winding factor is not given in this problem. If it is not given, you can assume standard value. Let stator winding factor as 0.955. So you may assume in the range of 0.95 to 0.96. No problem. So next calculation goes to output coefficient C naught. C naught equal to 11 times kWs B average AC into 10 to the power of minus 3. All values are available, directly substitute. Then we are going to get C naught value. So after knowing these three parameters, then you take the output expression Q equal to C naught D square L NS. From this expression we have to separate D square L. Hence you have to develop the expression for D square L and go on substituting the values. Then you should get equation number 1. So D square L equal to 0.00054 meter cube. You go on writing the formulas and substitute and solution. This is standard way. So L by tau we needed to separate the D and L. Another factor is required. L by tau. Tau is pole pitch. Tau equal to pi d by p. Hence L equal to tau equal to pi d by p. So I am going to get L equal to 0.7853 times of D. Equation 2. Hence you substitute this value in D square L, that is from equation 192. I am going to get D equal to 0.19 meter, L equal to 0.15 meter. This completes your 50% of problem. You may get up 5 to 6 marks. Then we know that B average equal to P pi divided by pi dl. Hence next I want to determine flux per pole phi m from above expression. So phi m equal to B average into pi dl divided by P. So we are going to get as 0.01 Webers. What is the type of motor stator connection has? Whether it is delta connected, whether it is star connected. you write down the thing, because I have to know phase voltage. The phase voltage is required. Hence, given voltage in the problem is always line voltage. Hence, line voltage is given 400 volts. So, motor is delta connected. Phase voltage also becomes 400 volts, sir. Then from the induced EMF for phase expression, EP equal to 4.44 F5M kWs TS, where kWs is stator winding factor, TS is number of stator turns per phase. Hence, we have to frame the expression for TS. Hence, you substitute. I am going to get TS equal to 188. Next one, selection of stator slots. The selection of stator slots should satisfy 2 points. Number 1, the stator slots should be a multiple of Q, where Q is slots per pole for phase. Hence, we have to make this one. What is the value you are taking slots? That should be multiple of Q. Hence, by trial and error method, we have to calculate total stator slots. Number 1, for Q equal to 2. So, stator slots equal to number of phases, number of poles into Q. So, Q equal to stator slots per pole for phase. You have to multiply poles, you have to multiply phase, then we are going to get slots. For Q equal to 2, it is 24 and go on. After that second condition, stator slot pitch should lie between 15 mm to 25 mm. Second condition. Hence, I have to check all these values. Number 1, SS equal to 36. So, YSS equal to pi d by SS. Pi into D. 0.19, it is in meter, convert into meters. 0.19 into 10 to the power of 3 divided by SS 36. So, we are going to get as 16.58 mm. Hence, SS equal to 36. This lies, the slot pitch lies in between 15 mm to 25 mm. Hence, my final selection is SS equal to 36 for stator slots. Then I have to know conductors per slot, ZSS. ZSS equal to total stator conductors divided by total stator slots. Conductors per slot, total conductors divided by total slots. So, for 3-phase induction motor, I am knowing the TS. 2 TS equal to 1 conductor. 2 turns equal to 1 conductor. How many phase? 3 phase. Hence, it becomes 6 times of TS. So, 6 TS is total conductors divided by 36. So, I am going to get 31.33. So, the conductors per slot should be an even integer for double layer winding. Hence, final selection is 32. ZSS equal to make the even integer 32. Hence, as per this consideration, total stator conductors becomes SS into ZSS. That I am going to get L152. Then, as per this final value of conductors, new value of stator turns per phase, TS equal to ZSS into SS divided by 6. So, TS equal to 192 as per the new value of stator slots. In similar fashion, we have to go for second number problem. It is asked number of times in VTU examination. Estimate the stator core dimensions, number of stator slots, number of stator conductors per slot for a 100 kilowatt, 3300 volts, 12 pole, star connected, slip ring, IM. B average 0.4 Webers per meter square, AC 25,000, efficiency 0.9, power factor 0.9. Choose the main dimensions to give best power factor. The slot loading should not exceed 500 ampere conductors. Here you see that best power factor condition is given. You have to remember for best power factor what is the L by tau value we have to consider. That's why it is very important problem. So you write down the given datas one side, then you start as usual previous problem. Number 1, kVA input, again output is given in kilowatt, output divided by efficiency into power factor, so 123.4 kVA. Then again stator winding factor is not given, so I have assumed this value kW as 0.96. So next calculation, output coefficient C0 equal to 11 times B average AC into kWs into 10 to the power of minus 3. This value we are going to get around 105.6. You go on substituting the values and calculation. Second, I have to calculate synchronous speed ns equal to 2f by p. You substitute a value 8.3 revolutions per second. Then q equal to c0 d square l ns. D square l, that should be equal to 0.1403 meter cube. Develop the equation number 1. For best power factor, we know that tau equal to under square root of 0.18 times of L. Remember this value. So tau equal to pi d by p. So this pi d by p equal to under square root of 0.18 times of L. Then you squaring on both sides. It becomes pi square d square p square equal to 0.18 times of L. Therefore d square, you develop the equation d square equal to 2.62 times of L. Hence, solving the equation 192, we are going to D and L values. From equation 192, D square L equal to 0.1403, you substitute the value, we are going to get L as 0.23 meter, D is 0.78 meters. Now the stator is star connected. In this problem, stator is star connected. Then voltage per phase EL by root 3, 1905 volts. So from help of B average equal to P pi divided by pi dl. Hence you calculate the flux per pole phi m, 0.187 Webers. Then induced EMF expression, calculate the stator turns per phase TS equal to 478. The stator slot pitch should lies between 15 mm to 25 mm. We are knowing the YSS, slot pitch equal to pi d by SS. From that expression, stator slots equal to pi d by slot pitch YSS. Hence, we have to know when slot pitch equal to 15 mm, what is the value of SS. So you substitute YSS equal to 15 mm. Here I converting into meters because 0.78 diameter equal to 0.78, it is in meters. So you have to convert YSS value also in meters, that is 15 into 10 to the power of minus 3. So here both units are to be same, meter meter or millimeter millimeter. In previous problem we have taken in millimeter. You understand? So SS equal to 163. Similarly, when YSS equal to 25 mm, that is slot pitch equal to 25 mm. So number of stator slots required are 98. Now you are getting minimal number of slots and maximum number of slots. From this calculations, it is observed that the stator slots selection should lies between 98 to 163 roughly. Hence, the stator slot should be a multiple of Q, second condition. Then you go on calculating all possible values in this range. So, number 1, Q equal to 2, calculate, you are going to get 72. Similarly, you follow up to 5, that is, which should satisfy from minimum to maximum range. Calculate all possible values. Now you can see there which are stator slots values are eligible. Number 1, Q equal to 3, we are going to get around 108, correct? Q equal to 4, again stator slots we are going to get around 144. If I go for Q equal to 5, then I am getting 180, hence 180 is not eligible and 72 is also not eligible. So as per above condition, stator slot should be 108 or it may be 144. Getting the idea? Very important decision from checking of slot loading, whether we can use 108 or whether we can use 144. Before that, you calculate the stator current. Stator current per phase equal to KVA rating into 10 to the power of 3 divided by root 3 times of EL. So you can use this expression or you can use very simple stator current per phase equal to KVA into 10 to the power of 3, that is KVA rating in volt ampere per phase divided by phase voltage. Which one you feel easy, you can take. This is very easy. Second one, stator current per phase equal to KVA per phase, it is in volt ampere divided by phase voltage. In this problem, star connection is given, hence EL by root 3. EL by root 3, you are getting the top expression. So stator current becomes 21.59 amperes. Then you check slot loading. Number 1, when SS equal to 108, so stator conductors per slot ZSS equal to total stator conductors 6 times of TS divided by total stator slots SS. So I am going to get around 26. Then you check slot loading. Slot loading, that means in one slot what are the number of conductors, then how much current flows, that is the slot loading. So in one conductor, one slot, how many conductors are there? ZSS. Then current flowing through each conductor, IS. So it becomes around 561.6 ampere conductors. Similarly, you can go same calculations for 144 slots. ZSS again 6 times of TS divided by SS, we are going to get around 20. Then slot loading, you check the properly, here it is wrong. So one value we are going to get around less than 500, it is wrong here. You all of you go properly, then see there. So you check that value, definitely it is less than 500 condition of ampere conductors. So therefore SS equal to 144 is my best choice, because SS equal to 108 we are getting slot loading above the 561, not eligible. When SS equal to 144 we are going to get slot loading less than 500 amperes conductors, hence final selection of stator slots equal to 144. Then actual stator conductors equal to SS into ZSS. So we are going to get around 2880. Thank you to one and all.